Welcome to Derivatives Lesson 3, Basic Differentiation Formulas. Now that you've spent some time trying to work with the definition of a derivative to find out what the derivative is, now we're going to show you the easy way to do it, which is typically true of any math course. They make you do all the hard work and then you learn how to do it the easy way. But that way you appreciate the easy way more. And once, I think I've said this before, derivatives are all about the slope of a curve at any given point. Remember, it's the slope of a curve at any given point. So before we talk about those, I'd like you to see some ways that sometimes derivatives are written. Okay, the two on the top here, this one and this one, those are Leibnizian notation. The one on the left here says the derivative of f of x with respect to x. So this here says the derivative of y with respect to x. Leibniz is one of the co-founders of calculus. He and the guy he was competing against pretty much published right around the same time, and they both kind of like put it all together. And then the two notations down at the bottom are attributed to the other founder of calculus, Sir Isaac Newton. This is Newtonian notation, f prime of x or y prime. And it just seems like it's easier to write these, although there are going to be times where we use Leibnizian notation to help us write down derivatives. So, hey, let's have at it. Let's talk about some basic differentiation formulas. If f of x equals 6, okay, you should be thinking y equals 6. Come on, what kind of line is that? Yes, you're right. That's a horizontal line. What is the slope of that horizontal line? F prime of x equals 0. There is no slope to that line. So the derivative of 6 is 0. Okay? G of x equals e to the fourth. E to the fourth is a constant, which means this is again is going to be the graph of a horizontal line. The slope of a horizontal line, 0. G prime of x equals 0. Got it? Get it? Good. Okay, those are constant functions. Their derivatives are always going to be 0. Let's go ahead and move on. Alright, now we have some, and yeah, the reason I pause is because I'm going to mess up this page. I can go back and restart it with that pause there so that I can restart it without over-talking myself, which you would not believe is very difficult. Alright, f of x equals 2x. Okay, that is a line that goes through the origin and has a slope of 2, so f prime of x, the derivative of fx, is 2 because it has a slope of 2. G prime of x has a y-intercept of 16 and a slope of pi, so the derivative of g of x, g prime of x, equals pi because that's the slope, that's the coefficient, that's the m for that linear function. Did I say too much too fast? That's a cool thing about pausing and rewinding, isn't it? And doesn't this just make you mad that all you have to do is write that down? Yeah, it's okay. It's going to get worse. Alright, how about if g of x equals some constant times linear function? Well, guess what? G prime of x is just going to be 1.765431 times 2. That's all it is going to be. So I don't know if I can do this off the top of my head, but I'm going to try. 3.53 0, 8, 6, 4, 2. How did I do on that? I don't have a clue. I'm going to pause and check. Hey, not bad for an old duffer. Okay, f of x equals 4 times the expression 6x plus 4. Well, what is the derivative of this 6x plus 4? 6. With that constant out front, f prime of x is going to equal 24. And look, if you wanted to distribute this out first and then find the derivative of it, well, okay, the derivative of that is 24x. Yeah, all right. The derivative, sorry, is 24. Moving right along before I trip over my tongue any more than I have already. Okay, how about some other functions that aren't not necessarily linear, like a quadratic or rational functions? All right, this is how we're going to do it. Are you paying attention? We're going to take this 2 down, and we're going to move it down to the front as a new coefficient, and then subtract 1 from this 2 and make it a 1. So that would be 2 times 3, 6x. Can you believe it's that easy? No, really, it is. All right, this one's a little bit different. This is going to be a constant, negative 3 halves times x to the negative 1. So we're going to write the numerical coefficient, and then we're going to move x up into the numerator and give it a negative 1 power. But once again, what we're going to do is we're going to take that exponent of the x, move it down front as a coefficient, and subtract 1 from that. So it is going to be minus 2. Negative 1, subtract 1. So negative 1 times negative 3 halves, that's going to be 3 halves times x to the negative 2. Now we'll make it a positive exponent, throw it back down in the denominator. 3 over 2x squared. Oh boy, that's like magic, isn't it? It really is kind of like magic, isn't it? Okay, how about, wow, I got really lazy here. This is h prime of x equals 6x, and f prime of x is 3 over 2x squared. How about g prime of x here? All right, we're going to rewrite it as a fractional coefficient, 2/5, and then we're going to write it as x. Okay, bring that up to the numerator, and it'll be a negative 2 then, to the negative 2 power. Move that down front as a multiplier, negative 2 times, and subtract 1 from negative 2 to make it negative 3. All right, this negative 2 is a fraction, negative 2 over 1. Some of you still struggling with that. So negative 4/5 x to the negative 3, and then we will go ahead and move this x back down in the denominator. So g prime of x equals negative 4 over 5x cubed. And yes, that's going to take you some practice to where you can get that. But you will get better at it. Believe me, you will get better at it. All right, let me show you just a couple more, and you'll be done for the evening. All right, here we are. Oh my goodness, what's going on here, Mr. Manning? Okay, what is a fractional exponent when you've got a square root? Okay, in your brain, or if you need to write it out, go ahead and write it out. That would be 1/2, x to the 1/2, minus 5x to the 7th, plus 4x. So f of x equals that. So f prime of x is going to equal, move that exponent down front, x, sorry, 1/2, x, subtract 1 from 1/2, and you get negative 1/2. So that's going to move x down in the denominator with an exponent of 1/2. So f prime of x is going to equal 1 over 2, and that would be x to the 1/2, but we just know that that's root x. Alright, now let's deal with the rest of it here. Move this 7 down front, minus 35, subtract 1 from 7, x to the 6th, plus, okay, that's just a linear function part right there, plus 4. Alright, g of x equals the cube root of x plus 2. So we're going to rewrite that as an exponent. G of x equals x plus 2 to the 1/3. So g prime of x, here let's give us just a little bit more room so we can work on this. G prime of x is going to equal 1/3 times the expression x plus 2, subtract 1 from 1/3, and that would be negative 2/3. Move it downstairs. G prime of x equals 1 over 3 times x plus 2 to the 2/3. So we're squaring it, and because it's to the 1/3, we're taking the cube root of it. So we will write it one more time just for yucks to make it look almost sane. The cube root of x plus 2 quantity squared. And that's what g prime of x would be. So that is the simple way to deal with functions that are constant functions, linear functions, polynomial functions, some rational functions, and some root functions. Anyway, this will end lesson 3 on basic differentiation formulas. And I know you guys are going to come in and just yell at me. Why did you do that to us, Mr. Manning? I'm sorry, but that's the way life is. Have a great evening, and I'll see you tomorrow.